So we're now going to go into sketching quadratic equations. Now remember, quadratic equations graphically is just a curve, right? Remember, we have done straight lines before, where the format of that is y equals to mx plus c, and this gives you a straight line, right, graphically, while this right here gives you a curve. You either have a positive curve or a u-shaped curve or a negative curve, meaning an n-shaped curve. Now, how do you know whether it's going to be a u-shaped or an n-shaped? You look at the a value. That means the coefficient of your x squared. That tells you the shape of the curve. Okay? Now, why would you need the shape of the curve when you are sketching a quadratic? Obviously, you need to know how it looks, because there are two ways it can look, a u or an n. What are other things that you need when sketching a quadratic is where the position on the graph is. So for that, we need a few coordinates, mainly the intercepts, meaning the x-intercept where it touches the x-axis, and the y-intercept where it touches the y-axis. You should know this from IGCSE, but for your x-intercepts, your y is equal to 0, and for your y-intercept, your x is equal to 0, okay? So once we get these two things, so the general shape of the graph, which we get from the value of a, if it's a positive, then it's going to be a u. If it's a negative, then it's going to be an n. The intercepts, x-intercept where y is 0 and y-intercept where x is 0. And finally, the coordinates of the vertex. What exactly is the vertex? It's the turning point of the curve that splits that curve into two symmetrical parts. So that curve, that vertex, if you draw a line down the middle of that vertex, that will be a line of symmetry, meaning the left side would be equal to the right side. Okay? Now, let's do some examples of how exactly we would get those sketches, right? So firstly, by factorizing, we start off with our original equation, x squared minus 3x minus 4, and we know the shape of the curve, right? It's going to be a positive quadratic because the a here is positive 1, which means it's going to be a u-shaped curve. Okay? And then what else do we need? We need the vertex, and we need exactly where it touches the x-axis. Right? So suppose these are the xy, this is the xy plane, and we want exactly where it touches the x-axis, and where it touches the y-axis, and also the vertex. We need the coordinates of all of these. Now, how exactly would we get that from our equation? By factorizing. So firstly, let's just factorize this. We would end up getting x minus 4 and x plus 1 equals 0, right? And you do know that if you solve this equation, you would get the x-intercepts directly. Why? Because this is just y equals to x squared minus 3x minus 4. And if we factorize it, y equals to x minus 4, x plus 1. And if we let y is 0, if y is equal to 0, we are basically looking at the x-axis, right? So the values of x we get from this are the values at which it intersects the x-axis. So the 2 points are x equals 4 and x equals negative 1. So here probably be 4 and here would be negative 1. And remember that a quadratic curve is symmetric, meaning these 2 points exactly in the middle will be our line of symmetry, and that's how you would get that reflection. And therefore the x coordinates of your vertex would be in between negative 1 and 4, the two roots of that equation, right? The value between negative 1 and 4 is going to be 1.5, right? And so x equals to 1.5. That's going to be the x coordinate of this, 1.5. From that, we can find our y coordinate. How? We can put it back into our equation of the quadratic, because remember, this is a quadratic graph. And if we put in our x value, we're going to get our f of x value, which is the y value. So if we put in 1.5 squared minus 3 times 1.5 minus 4, we get y equals to negative 25 over 4, which is just negative 6.25. And this is what we get as our vertex. Finally, so we have our x intercepts, we have our vertex. We just need one more thing for our sketch. We need the y-intercept. Remember, y-intercept, x is 0, or you can just see the independent term, which is -4, which was the c in the ax squared plus bx plus c. The c is your intercept, right? And your c is -4. So we have three things that we needed. We have the shape, which is a U shape, because it's a positive quadratic, okay? Then the intercepts, the x-intercepts are -1, 0 and 4, 0. And the y-intercept is 0 and -4, because that's the c. And finally, we needed the vertex coordinates, which is just 1.5 and -6.25. And we have the three things for sketching, and that's how we drew this curve as it is. Okay. Another example using a different method, completing the square, which I think is the easier way of doing it, right? So whenever you're completing the square, you take your quadratic equation. Let's just write it nicer. So -4x squared plus 16x minus 7. I won't write it in that format, right? The ax squared plus bx plus c. Here a is -4, b is 16, and c is -7. I would want to complete the square here, and to complete the square I would take this c and put it aside and just work with this right here. And what I would do first is I would factorize at -4. So -4 x squared minus 4x, right? And obviously I have my -7 at the end. And then after that I would complete the square for this. And this would make it -4 x plus b over 2 squared minus b over 2 squared. Right? And then you have my -7 outside. What is b in this case? B is your coefficient of x. So this becomes -4 x minus 2 squared minus -2 squared, which is just -4 open bracket x minus 2 squared. This becomes -4 multiplied by 4, you get plus 16 minus 7 at the end then, right? Because this thing right here is going to be -4, and if you multiply it by the -4 outside the bracket, you get positive 16. Then you subtract -7, you subtract 7 at the end, and you end up with something like this. So -4 x minus 2 squared plus 16 minus 7 is plus 9, right? And you have this right here. Now from this, how exactly do we get the shape, the intercepts, and the vertex? Shape, pretty clear. The number outside the bracket is going to give you the shape, or you could just see directly from your original quadratic equation. It's a negative in this case, so our shape is going to be an N shape. Okay. You can find your intercepts. So y-intercept, your x is 0, or the independent term in your quadratic, so -7. So your y-intercept here is -7. So it's 0, -7. Your x-intercepts are the solution of this equation. So after you solve this, make it equal 0. This will become x minus 2 squared equals 9 over 4. Square root both sides, so x minus 2 equals 3 over 2 plus or minus. And this will give us x equals 3 over 2 plus 2 and -3 over 2 plus 2. Okay, and this would give me 7 over 2, so 3.5, and this would give me 0.5. And these are going to be your two values of x, so your x-intercepts. Finally, your vertex, you can see directly from your format that the complete the square format that you had, where if you make this equal to 0, the stuff inside the bracket, the x minus 2 equals 0, and that gives you x equals 2. And also you look at your thing outside the bracket, so your 9, the 9, that will be your y coordinate. And so to get your vertex, you just solve this and equate it to 0 to get your x coordinate of your vertex, and the number outside the bracket will be your y coordinate of the vertex. And so your vertex will just be 2, 9. So your shape is an n, your intercept, your y-intercept is 0, -7. That means it intersects below. Your x-intercepts, which are the solutions for your quadratic, are 7/2 and 0.5, so 3.5 and 0.5, which obviously between those will be your vertex x coordinate. Because remember, the vertex is your line of symmetry of the two, right? And so your curve would end up looking something like this. And so your curve would, the vertex is 2, 9, so 2, 9 somewhere here. It obviously touches the y-axis when y is -7, so it's going to be somewhere below, and something like this. Obviously it's an n-shaped. This vertex is 2, 9. The 2 points at which it meets is 3.5 and 0.5. This is obviously a line of symmetry, which is at 2. And finally, this point is -7, because that's where it intersects the y-axis. And this is going to be the sketch of your curve. Okay. Finally, let's take a look at the quadratic formula and how you can also use that to sketch your curve. Okay. So generally, your quadratic formula looks at your quadratic equation, which in the general format is ax squared plus bx plus c. And to solve it, you do -b plus or minus square root of b squared minus 4ac all over 2a. And this basically gives us -b over 2a plus or minus the square root of b squared minus 4ac over 2a. How do we get this? This is just a general thing about, if I have a fraction a plus b over c, I can split it into a over c plus b over c. And if I start off with this, I can end up with this, right? And that's what they're doing here. And so your two values, your two x values for this, which are your x-intercepts, remember, are going to be -b over 2a minus, yes, and -b over 2a plus. And obviously in between, which is your vertex, because remember your line of symmetry is exactly, the x-coordinate of your vertex is exactly in between your two x-intercepts, just because it's symmetrical, right? And that's going to be right in between, and so the x-coordinate is going to just be -b over 2a. So whatever your b is and your a is from your original quadratic formula, quadratic equation, you can use it to get the coordinates of your vertex. Then to get your y coordinate, obviously you would put that -b over 2a into your original quadratic equation. And finally, we know that our y-intercept is always the independent term of x from your original quadratic equation. That's how quadratic formula is used. Now let's just look at an example to make it practical. And we need to sketch 2x squared plus 3x minus 4. And we're going to do that as we did in our example, our general example, where firstly, we'll start by using the quadratic formula. X equals to -b plus minus square root b squared minus 4ac all over 2a. And we can split them. Let's put in our values and split them as well. So x equals -3 over 2 times 2, which is 4, plus or minus root of b squared, which is 9, minus 4 to -4, which is just going to be 9 plus 32, which is 41. And so square root of 41 over 4. And that's going to be our x values. So if you're looking at the sketch, is it going to be a U-shaped or an N-shaped? It's going to be a U-shaped because our a is positive. Our two values that it touches at is going to be -3 over 4 minus root 41 over 4, which is going to be a negative value, and -3 over 4 plus root 41 over 4, which is going to be just slightly positive, right? And the vertex is going to be at -3 over 4, which is -b over 2a. So negative 3 over 4 is going to be your vertex. So somewhere here, that's going to be the x-coordinate of your vertex. 3 over 4. Okay? So the vertex lies somewhere on this line. Obviously, we need the y value for that. And for that, we need to take this, the x-coordinate of your vertex, and put it into the equation of our quadratic equation. And we would end up with y equals negative 41 over 8 after we put this negative 3 over 4 into this quadratic equation. Therefore, the vertex is going to be somewhere down here. Okay, and we see that the way it goes, something like this. And that's going to be our sketch. Basically, it goes on forever. And we need one more thing, which is the y coordinate of the y-intercept, which is just going to be negative 4, the independent term, right? So this is negative 4. This is going to be negative 3 over 4 plus root 41 over 4. And this is going to be negative 3 over 4 minus root 41 over 4. Yeah? And the vertex, this is going to be negative 3 over 4 with negative 41 over 8. And that's how we can use factorizing, completing the square, or the formula. Use whatever method you like the most in order to sketch a quadratic graph. So, onto the quadratic inequalities part, which is also a very important part for this topic. First, before we go into the more advanced stuff, let's just rewind and do whatever we did in IGCSE. And for that, we need to be able to solve these two quadratic equations, right? Quadratic inequalities, sorry, right? For this one, you just treat this as an equal sign and solve it the same way as it is. So 2x plus 14 less than negative 4. Take this to the other side. 2x less than negative 18 and x is less than negative 9. Yeah? Treat it as an equal sign and do the exact same thing all the time. Same thing for this. 11 minus 2x greater or equal to 5. Take this to the other side. Negative 2x greater or equal to 5 minus 11, which is negative 6. Then remember, if you are dividing or multiplying by a negative number, then the sign flips. So that's the only caveat, which is the difference between treating it as an equal sign and treating it as an inequality. Right? And for here, we'll get x less than or equal to 3. Okay? And so that's how we usually solve inequalities. Now, when you're looking at quadratic inequalities, we need to first start off by sketching. This is why we did the whole sketching section. We need to first start off by sketching the graph. So let's just go back to sketching this. And how did we sketch this usually? We would find the roots of this, right? And the shape of it. So obviously this is a U. Okay? It's going to be a U shaped. And sketching this, you'll need the x intercepts, right? And for that, let's just use the factorization method. So x minus 7, x plus 2, that is factorizing this, equals 0. So x equals 7 and x equals negative 2. So at negative 2 and at 7, we have the x-intercepts and it looks something like this, right? And we don't really need anything more. So what did we do? We changed the inequality into an equal sign and we sketched the graph, right? Now, looking at exactly what's happening, we are looking at values that are greater than 0. Obviously, 0 is this line right here, the x-intercept, and these points are negative 2 and 7. And if we are looking at it as greater than 0, so obviously we can see that the values that are greater than 0 are these right here and these right here. So what we're looking for is every x value, obviously we are solving it in terms of x, every x value that is less than negative 2, yes, and obviously every x value that is greater than 7. And these two are going to be the solutions of this quadratic inequality. Okay? So that's how you are supposed to solve quadratic inequalities. Let's do another example where 2x squared plus 3x less than or equal to 27. Again, we could start off by sketching the curve. So 2x squared plus 3x minus 27 less than or equal to 0. We can start off by sketching it. And for that, we equate it to 0, right? And we can factorize this. I'll just do it quicker. So 2x plus 9, x minus 3 equals 0. That's factorizing it and equating it to 0. This just means 2x plus 9 equals 0 and x minus 3 equals 0. This would give us x equals to negative 4.5 and x equals to 3. And these are going to be our two x-intercepts, right? Remember, if you solve anything equating to 0, those are going to be your x-intercepts. Now, the shape of the curve, a u, because our a is positive. And so we have this information up to now. We have our graph. We have the curve that it's a u intersects at negative 4.5 and at 3. Let's just say this is 3. Let's just say this is negative 4.5. And we're looking at all values that are less than 0. Obviously, if we look at the graph, we can know that those values are going to be these ones here. Right? These are all less than 0. Obviously, this is the 0 line where the x-intercepts are. And so, everything lower than that are your values of x that you're interested in, which is everything greater than negative 4.5 as well as less than 3. So you're looking at this section right here, between negative 4.5 and 3. And so that's going to be our solution for this inequality, where x is between 3 and negative 4.5. So negative 4.5 is smaller than x, which is smaller than 3. That's going to be our solution for this inequality. Okay. Let's do one more example where we need to solve this first. So again, do the same thing, where we can equate it to 0. So negative x squared plus 6x plus 16 less than 0. And we could solve this equation first, or we could divide by negative to remove this negative. It's going to give you the same answer. So let's just divide this by negative, because that's what I have in my solutions from the notes. So if I divide by negative all sides, this is going to be x squared minus 6x minus 16. And obviously, if you're dividing by negative, the sign changes, remember? So greater than 0. Then we can sketch this curve, and we can do it by factorizing. So x minus 8, x plus 2 equals 0, remember? And this would give us our two x-intercepts as x equals 8 and x equals negative 2. And so we would have our sketching. Remember, this is going to be a U-shaped curve because it's a positive. Remember, we changed it into a positive, where our intercepts are at negative 2 and positive 8. So something along this line, right? And this is going to be our thing. And we are looking for greater than 0. So we are looking at this part and this part, which means we are looking at everything less than negative 2 to the left of negative 2. So x less than negative 2 and x greater than 8. Okay, try out doing it as it is. Okay, so doing it in the form that it's given. So solve the negative x squared plus 6x plus 16 less than 0. Draw your curve and see if you're finding the values less than 0. So if you're looking at the bottom part, see if you would get these two of the same answers. You should be getting the same answers. Okay, and then for B, Roman 1, let's just go to the next slide. You need to show that x squared minus 2x plus 2 is greater than 0 for all real values of x. Now, whenever you're doing that, you need to complete the square. Now, the reason we complete the square is, I'll show you right now, right? So let's just complete the square here. X minus 1 squared plus 1. And that's going to be complete the square version of this. You can do it on your own and you should get this. And now we need to check if this is greater than 0 for all values of x. So remember, if I have a positive number and I add it by another positive number, could I ever get a negative number? No. Everything will be positive. Yes? 1 plus 2 or 1 plus 3 or 1 plus 5 would never be negative because they are two positive numbers that you're adding to each other. And that's the idea that you're going for here. So if you look at the first term, x minus 1 squared. Is that going to be positive always? Yes, because it's a square. Remember, the smallest value a square can be is 0, right? And then you are adding it by another positive number. I'm adding it by another positive number 1. And so this is always going to be greater than 0. Why? The smallest value this can take up is 0. And if this takes up 0, which is the smallest value it can take up, and you add 1 to it, it's going to give you 1. That means the smallest value this entire equation as a whole can give you, for any value of x, the smallest value would be 1, which is always going to be greater than 0. Every value after that is always greater than 1, which is obviously going to be greater than 0 as well. And so, yes, this equation, this quadratic, is always greater than 0 for all values of x. We showed this by completing the square. Okay? Then we need to solve this thing right here. Now to solve it, we need to look at a few things, which is, we can just bring this to the other side, where x greater than x squared minus 2x plus 2. Okay? Then we can rearrange it and we end up getting 0 greater than x squared minus 3x plus 2. And we can write this from the left, right, so it's easier to read. X squared minus 3x plus 2 less than 0. And after this, we can just do the same thing, like sketching and all that, right? And we can factorize x minus 1, x minus 2 equals to 0. And it's going to be a U-shaped curve, and it's going to look something like this. Negative 1 and, sorry, it's going to be positive 1 and positive 2. X minus 1, x minus 2, so x equals to 1 and x equals to 2. And our y-axis is going to be here. And it will look something like this, right? And so the solution for this, which is going to be less than 0, is what we are finding, right? So we want it to be below this line. And obviously the values of x that allow us to go below this line is every value of x between 1 and 2. Because between 1 and 2, we're going to get the curve below the x-axis, which is the 0 line, right? So our answer is going to be less than 2 and greater than 1.